Hello and welcome back to Ronnie Explains. So, did you know that in the design of a gray code decoder, you don't just need to implement it using OR gates or AND gates. Like for example, if you look at our previous design in the video that I made earlier about gray code decoders, our design looked something like this. And if you look at this design, all the implementation was done using AND gates and OR gates. But we can also do the same implementation using XOR gates. If you look at the spreadsheet document of this circuit, this is how it looks like. Now this spreadsheet document here, this other side we have the kernel maps and the logic expressions. And this side here we have the truth table that contains the input values and the uh, gray code equivalence of these binary codes. So this is what I'm simply going to do. I will relaunch my software, Hades software, and then do the implementation of this logic expressions here. So I will come to Hades, then open a new uh, workspace. So in this new workspace here, I will do some few setups. The instant labels and the port labels are already set up. Then I will come to view and use a magnetic grid of 1/8 inch. Then I'll just reduce this window so that I can do a comparison between what I'm working on and the logic expressions on this other in this other window. So this is what's gonna happen. I will come here and create my input switches. So I'll create IPin switch and there are 4 of them. So I'll have 1, 2, 3, and 4. Now these IPin switches that I have here, I will name the first one as D, then I name the second one as C, then I name this as B, and finally I name the last one here as A. Then after this, I don't need to use inverters because I am purely going to use the XOR gates. So what I am going to do here is that I'm going to check the XORs that I have. If you look at the logic expressions for C out here, then you realize that C out is C prime D or C D prime. And then B out is B C prime and B prime C. And then the last one is A prime B and AB prime. It means that I can have these values. I can have an XOR between A and B here. So the XOR between A and B is going to be down here, then the XOR between B and C, then the XOR between C and D. And then the first expression is simply a single signal, so I'm not going to uh, care about it much because it doesn't require any gate. So I am going to have 3 XOR gates. So I'll come here and create XOR gates, but the ones that are having 2 inputs. The first one, I'm going to put it here. Then I put my second one here, and then I have my third one here. I'm going to name the first one here as C XOR D. And the reason for naming it like that is because C XOR D is the same expression here. This same expression is the same as C XOR D. The second one is going to be named as B XOR C. Then the third one is going to be named as A XOR B. Then I will put my output LEDs on this other side, and they are supposed to be 4 of them. So this is what I am going to do. I am going to simply create an output LED and then paste it here 4 times. So I'll have this, and that. Now the name of the first one here is going to be this first one, which is D out. Then the name of the second one is going to be C out. The name of this third one here is going to be B out, and then the name of the fourth one is going to be A out. So now we have all these LEDs named, and I am just going to now implement the logic. I'm going to connect my input switches to their corresponding gates. So for example, A and A, X, or B are going to be here. So this is A, X, or B. Then I will have in this point here C and B also forming XOR. So I will add a wire segment here and then connect this with C. Then for C, X, or D, I will have the first one, which is D here, and maybe move this a bit up here. Then connect this with this, and after that, combine this with C. Now C is this wire here, so I'm going to pick it from here, add a wire segment, and connect it to this XOR gate. So now I have this logic implemented. On this other side, I am simply going to connect them to my output LEDs. So right here, the first one was the value of A because, sorry, the first one was the value of D out. So I'll come here and then I add a wire segment. So I'll come to wire, then add wire segment and connect this to D out, which is simply here. Then now the second one, which is C, X, or D, is going to be connected to C out. So this will be connected to this. Then I will have this one here being connected to this, and finally this being connected to this. And just like that, I can maximize this window and view the full design. So this is the design that we are having. If you want to test this design against the truth table, then it's also okay to minimize the window and view it against what we are having in our spreadsheet document. So I will come to this spreadsheet document and check my binary codes against the gray codes. I will just do some few random checks to see if the circuit is working correctly. So the first one that I'm going to check is this one here because the output has a value of 1, all of them. So I'll click 1, 0, 1, 0 in the input. So this will be 1. So activate the inputs first, then this is 1, 0, 1, 0. And if you look at the output side, then you see that everything is on, just like this other side, everything is also on. And if I check another different one, for example, here 0, 1, 1, 0, this one here, I expect to see 0, 1, 0, 1. So 0, 1, 1, 0, I expect to see 0, 1, 0, 1. So those few checks, I can now create a sub-design of this circuit. So Control plus F to view in full mode, then I can save this work. So Control plus S. Now I want to save this work here as circuit 1. So I'll come here and create this as circuit 1 and then save it. Then I'll create a sub-design for this. So I will come to edit and create its symbol, and then come to file and open a new workspace and check if my instant labels and port labels are okay, and then come to view and use a magnetic grid of 1/8. So this is what I have. I'll right click and create it sub-design. And the sub-design is for this circuit 1 that we've just created, and I'll put it here. And this other side, I will create an hexadecimal display, and then I'll have it here. And then here I will have an hexadecimal switch. Then I will just do the connections like this, and this side also I will connect to the output. Then I'll name this here as gray code decoder. Then maybe I can minimize this window like this and view the full design. So I'll do a few checks. I'll come and click these decimal numbers to see the equivalent gray code numbers. Then you see that it's working the same way as the one that we made previously. So that's all for this video. I hope to see you in my next video.